Hello back, and last and very quick part for this class. I'm not gonna go very deep in it because, to be honest, you're not often will use it. I think, as long you do not work with really big data from tables from some online sources, and as always, you already know how to work with chops and tops. So we can do just pretty much the same with DATs. Let's for this I will create small table. Okay, let's first constant. I do not remember the value, but let's try TDU random. Run. So I need to give a 0 to 1. No. Okay. It works something like this. So let me create few tables. So one is gonna be, let's say, 100 rows. Gonna be one column. I will use evaluate here. I will create another table up here, and here I will set up to do run, so it give me some number. So this is seed pretty much. Okay, so I have different row. Let's get some constant from it. Yeah. So now I generate 100 random numbers with the first one. And I will create one more table. I will call it noise. And I will create execute, frame start, edit and export, import random, and on frame start I will do target equals noise. I will create another table here, call it data, target equals data. I don't need noise here. And for So this is I'm gonna do the same. 100 rows, 1 column. For E in range from 0 to target. Again, op data, yeah, to target. Num rows. What they're gonna do, and here one source equals op eval1. I will write target y0 gonna be source y0 plus random and okay, the random function by default will give me from 0 to 1. I will multiply it by 10 and minus 5. So now it's going to be from minus 5 to 5. Okay, and here I need to put so now I pretty much what I did here, I just simulated this random input from the sensors. For example, from the same leader you can get this input, something like this, right? Okay, so and how I gonna filter this data? Okay, one of the way, again here I can set up my cache, but I will need to set up it too by myself. So I will need to run another script. So for example, let's just call it data 1, data 2. And I will create another execute, and in this execute I will do text. I will call its average the same, and I can write average of average data equals of data pre1 equals op data 1, ref2 equals op data 2, ref3 equals op data 4. I will create one table, but it's gonna be 5 columns. I delete execute, frame start, average equals operator average, previous equals pop data 1, data equals op data. So in this folder, in this table, I will collect the last previous. Data value is so to calculate average after. For E in range from 0 to our num rows, I will go for each row to collect it. Okay, so first of all, what I need to do, I need to do the so first of all I will go previous y 0 gonna be okay y4 will become previous y3 previous y3 will become previous y2 previous y2 will become previous y1 previous y1 will become previous y0 and previous y0 will become data y0. And some error, name O is not identified, 28, it's okay. Okay, for this I need to set up also how many rows I have. Okay, now you see here I have all data for previous 5 frames, and now I can do also other y0 we're gonna go previous y4 plus previous y3 plus previous y2 plus previous y1 plus previous y0 and all of this I will divide by 5. So now here I will have average. So, and okay, I can do much more complex things with it. Usually I will need to do, but you see it's required kind of a lot of computation. But what I can do with this, I can just transform output channel per row. First row is values, first column is values. This one, this is gonna be second one. You see this one already not so noisy. And again I can do trail to see here how the signal go. And let's for this one we just will select first 5 to see how it's work. So you see this one is already better, but it's still noisy. So to get my original value I need to do kind of more. Again I can go here and do analyze with average, and let's do this one the same. So here you can see here is not analyzed. So you see how data here, it's very noisy. Here is a little bit better, here is more better, and here is the original one. So it's quite close, yeah, to the original one we have now with all our noise. But again, why we just do not go and do not do everything what we did in the chop filtering. We just convert our data to the chops, and we go and through all this data the same way as we work with chops. It's gonna be much faster. I can easily change the time here or how many samples I wanna be here, yeah, just by using the simple trail again. So you always can have a more clear way to use it. Or you can go even more far away. You can convert it to the top. And I can do mass here. And for mass I wanna, okay, when I convert to the top, I use this rock. And this one now from 0 to 100 around here. So I can tell from 0 100 to 0 to 1. So now we see it's much more, and we still, again, we can do all our top filtering, operation, composing on these channels to smooth it, to filter it, to get the better value. Okay, so this is pretty much everything for that for today. Again, not often you will go this way, as long you don't need really something, do some complex calculation. You always, either way, you transfer them to the chops and you data filtering on chops, or you to transform them to the tops and you do your data filtering on the tops. Okay, so see you next class. If any question, you can write in the chat group. I always will glad to answer you. See you.